So before we get started on free radical chemistry, let's talk about what free radicals are, because they are something that not a lot of people, you've heard it from dietary supplements, but you probably don't know what they are. So the most common radical you've ever worked with is hydrogen peroxide. Now peroxide on its own is not a radical. But what can happen is if we add something like iron. So if you've ever thrown hydrogen peroxide on an open wound, you probably notice bubbles. Why does it do that? Iron is a great catalyst at splitting this oxygen-oxygen bond. Now, both oxygens are equally electronegative. So when we split this bond, they both get their own electron. They don't take one or the other. And so we end up with what's called a hydroxy radical. We have oxygen here with 7 electrons in its coordination sphere and a -1 charge. Now these are two things oxygen does not want to do. It wants to follow the octet rule. It wants to have 8 electrons around it, and it will do whatever it can to add another electron. The second is that it now is in a -1. It would much rather be a -2. Because if it's -2, it attains the neon electron configuration and becomes stable. So, free radicals are when we generate an atom that has one unpaired electron on it. And typically what molecules will do that have a free radical, if they are a bigger bully than another atom, say something like hydrogen or carbon, they will take one electron away. So in the case of a bromine radical, bromine exists as Br2. We hit it with light, we're going to homolytic meaning that we're going to break, lytic being break, homo means the same. It gets homolytically broken into this. Now, bromine is more electronegative than hydrogen. So, given something like carbon or hydrogen, what it can do is it can steal the electron away from hydrogen and will create our carbon radicals. Now, again, your radical means that you have an unpaired electron. These things will do everything in their power to try to get rid of that unpaired electron. And they're going to do it either through resonance structures, which does a good job of stabilizing radicals, or they're going to do it by extracting one electron from another atom or bond. So, why did I say you probably have familiarity with these in terms of dietary supplements? If you've ever heard the term antioxidant, and this is a big catchphrase people like to throw in vitamins, your body naturally produces radicals all the time, either through UV exposure or just the simple fact that your body produces peroxides, it produces free radicals just by biological processes. Generally, they are benign compounds because there are natural antioxidants in your body. So what an antioxidant does is it reacts with a free radical and creates either a stable radical or it creates a molecule that does a good job of stabilizing itself. So the two radicals come together and they form a bond. Antioxidants are meant to remove free radicals. The reason why free radicals are so bad for your body is they have a habit of attacking whatever they can to get rid of that unpaired electron, like we talked about it earlier. It's fine until it starts going after the DNA, and that's when you start getting cancer. But again, your body naturally deals with it. But this is the idea of an antioxidant. It removes the free radicals. Now, that said, free radicals typically generated either by light with diatomic gases, or they are generated for big molecules like bromine or iodine through thermal separation, or big ones, peroxide. If we see the O2, and we'll talk about how to identify those in a later video, peroxides are a natural way to generate free radicals.